So, considering the free body diagram as shown here, we can see that the body is is generating a force F naught downwards. F3 is what is the question, so that the body moves with a constant acceleration. So since the body is going to move upwards, acceleration is also marked in the same. Okay, so the acceleration is also upwards. And we also note that since the body is moving upwards, the friction acts downwards. So the governing equation is F net total force is equal to mass into acceleration, right? So total we will calculate in a very similar fashion, right? So all the forces upwards are positive force, right? So that is F3 positive, uh, F3 minus F naught minus Fk should be equal to mass into acceleration, m into a. So let us try to solve this. That means F3 minus F naught is 52 minus Fk is 12 should be equal to mass, that is 6, into acceleration is given as 4. So this means the required force F3 is equal to 24 plus 12 plus 52. That is 88. 88 Newton. Okay, right. That's the solution. Right. Let's solve another problem of a very similar type. Right. Question still remains same, only the diagram. This is 50 degrees, 10.5 kilograms. Mu s is equal to 0.55. Mu k is equal to 0.35. Okay, so for a part C question, part A and part B still remain same. For part C, the acceleration has to be 5.8 meter per second square. Only that changes. Okay. Other than that, everything else remains same. All right. When we solve this, we get the answer like, okay, part A is of course F1 equal to 33.32 Newton. Yes. Part B question. Is 6.81 Newton, right? Newtons. Next question. Find the frictional force acting on the given block. So the block is 6 Newton. The weight is 2 kg. There is a force of 10 root 2 Newton, making an angle 45 degrees, and we have a force acting like this, which is 4 Newton. They have mentioned that mu s is equal to 0.6, mu k is equal to 0.4. So the question is that find the force of friction acting on this given block. So in this case, the first thing that we need to understand is that let's try to write a free body diagram first. Okay, so this is the free body diagram. So let us say this is the center of that object. Right. Now, how many forces are acting towards right? Right. One is 10 root 2. Anyway, the 10 root 2 will be split up into, say, two components. Okay. One is a vertical component, one is a horizontal. So, the horizontal component is 10 root 2 into cos 45. Okay. So, that is, there is a horizontal force acting on this body. That is 10 root 2 into cos 45. Cos 45 is 1 by root 2. So, there is a 10 Newton acting horizontal. Right. Then the weight of the body acts downwards. Okay, so that is 2 into, let's take G. G is equal to 10. So 2 into 10 is a 20 Newton downward. This is the weight. And also you see that there is a 6 Newton acting downwards, right? That's this. Now, there is what is called as, okay, another force, 4 Newton acting right side. So that's also can be marked here. That's this 4 Newton. Okay, then I can see that the 10 root 2, a portion of this, right, is going to act upwards, right? So upwards in the sense that is also 10 root 2 sine 45. So that is 10. Okay, this is the force that is acting upwards. I'll mark it as 10. So this is 10 Newton that is acting upwards because of this. Okay, we split that, and that is the amount of force which acts upwards. Okay, now next let us try to write this way. So always on the surface you have a normal reaction. Okay, I will mark that upwards. Maybe that is the reaction R. Right. Now, what is the frictional force is the question. So the frictional force is the net driving force, right, on this whole system. Okay, so let us try to calculate that. Now, so first let's calculate R. So R is equal to, R is upwards. So R plus 10 is equal to 20 plus 6 minus 10. So 20 plus 6, 26 minus 10 is 16 Newton. That is the force upwards. Okay, right? That's the normal reaction, right? When I have the normal reaction, right, I can find the amount of frictions, right? Two types of frictions can be calculated. So friction due to the static, right, is mu s into this normal friction. So this normal reaction R, right? So you can even call this as N, doesn't matter. So mu s into R. So mu s is 0.6 into 60. So that is 9.6 Newton. So Fk, the friction because of the movement or the kinetic, is mu k into R. Mu k is 0.4 into 60. Okay, so this is now 6.4 Newton. Now, what is the total friction, right? So friction should be in the opposite direction of this. So I will mark the friction in this, right? So the total driving force should be equal to, right, should be compensated by these two. Okay, so that's what is the meaning of this. So F is what I, so totally the object should not move. That's why F is equal to, required value of F is the net driving force that is opposite in the direction. Okay, so let us try to calculate the total F. Net F in the x direction is equal to only positive, so that is 10 plus 4, that is 14 Newton, right, to the right side. Okay, now I just have to find out, right, whether the total F is greater than Fs or Fk. Okay, if it is less than Fk, then the I have to find out the friction that is equal, that corresponds to the kinetic friction. Otherwise, if the friction is, the Fx is larger than that, then I can actually find out with the friction that is required as Fs. Okay, now I see that F is actually bigger than Fs into the mu s into r, right? So the friction that is going to act now will be the kinetic friction, because the force is bigger than this. When the force is bigger than this force 14 is bigger than this, means, right, is it moving? Yes, the block is moving now. Whenever it is moving, which is the friction that is acting? That is the Fs. Okay, so frictional force needs to be identified in that. Right. So either Fs or Fk will act. I have to decide that by just checking it with the following condition. The Fx, the total force, is bigger than mu s into r. Correct? So that is because 14 is bigger than mu s into r, that is 9.6. That means, right, it is not static. Static friction is not there. There is a, the friction is equal to Fk, because the body is moving, right? Whenever the force is lesser than this Fs or equal to this, body is still at rest. But now body is not at rest, the frictional force reduces, you have a new value of friction, that is 6.4. So this implies the friction of frictional force acting on this body is equal to 6.4 Newton. We'll decide it in this case. Okay. Also, there can be another question which I actually have not asked here, but anyway, there can be another question. Find the acceleration, because since the body is moving, there can be acceleration, right? You see, you can find out the total force 14 minus the frictional force, that is 6.4. They are opposite in name, opposite, divided by the mass. Mass is equal to 2 kg. That's given, right? You can find out this to be 3.8 meter per second square. Another, this is a different question if they ask.